Howdy folks, once again this is Donnie coming at you with another video about the post-quantum computing future. And the news this time involves OpenSSL, which is probably the most widely used encryption library out there. But anyway, OpenSSL 3.5 has been released. It was released on the 8th of April, which is about a month and a half ago, because I'm recording this on the 22nd of May of 2025. But anyway, the big news with OpenSSL 3.5 is that it has some new post-quantum computing algorithms enabled by default. You have MLChem, MLDSA, and SLHDSA, which are now all available for use, built right into the OpenSSL libraries. Now, previously, for the past couple of years, you've been able to add post-quantum computing algorithms to OpenSSL, but you had to jump through some hoops to do it. Had to add what was called a provider, which is kind of like a plug-in, and do a bunch of fancy configuration steps. Well, you don't have to do that anymore, because with version 3.5, we now have that already there for us. So, no more jumping through hoops. All right? And then, if we go over here, and we can look at this page here. This is from the National Security Agency here in the United States, and this concerns the Commercial National Security Algorithm Suite version 2.0, which is a set of requirements that the National Security Agency has come up with, which the version 2.0 of these a set of these requirements is not in force yet. Right now we're still on version 1.0, which does not involve quantum safe algorithms, but the 2.0 version does deal with quantum computing algorithms. Okay, so anyway, we scroll down here, and I should say too, I was going to say too that the plan is to start phasing in this new set of requirements at the end of 2025, beginning of 2026, and to have them completely in force in just a few years. All right. But anyway, if we scroll down here and we see a list of algorithms that they're going to want us to use, and we start out up here with our block cipher, which is just a fancy way of saying that's the encryption algorithm that will be used to actually encrypt the data that get transmitted between the server and the client. And so they're going to want us to use the Advanced Encryption Standard. Now, Advanced Encryption Standard, or better known as AES, has been around for quite a few years, so it's tried and true. The only change that they want us to make here is to use 256-bit keys. And currently you're going to find a lot of people out there, a lot of websites and what have you, are using 128-bit keys. And then down here we have the secure hash algorithm, which does our hashing, and that's also been around for quite a few years. And the only change we need to make there is to make sure we're using either 384 or 512-bit keys. And currently a lot of sites are using 256-bit keys. Now the new algorithms are the MLChem and the MLDSA, and MLChem is for key establishment. That's what comes up when we do our key exchange, and the MLDSA is for digital signatures. Okay, and the MLChem, they want us to use the 1024-bit key length. So 1024. Okay, keep that in mind. That's going to come in. We're going to talk about that more in just a few moments. Okay. So anyway, in order to do the demo of the brand new OpenSSL 3.5, I have to use a Seduction virtual machine here. Seduction is built on the unstable branch of Debian, and by unstable, I mean it's like the development branch of Debian. So as soon as a new version of a package comes out, it goes into that unstable branch of Debian, which in turn goes into Seduction. Okay, and Seduction's actually supposed to be a desktop Linux distro. I just disabled the desktop and just set it up as a server. Okay, now uh, we can look at our version of OpenSSL like this, and indeed we are using OpenSSL 3.5. Now your more stable distros, your enterprise grade distros have not switched to OpenSSL 3.5 yet. So if you want to play with OpenSSL 3.5, you got to use some sort of a rolling release distro, okay? And of course, in this case here, I'm using Seduction. And for the desktop, for my workstation operating system here that I'm using to record the video, I'm using the rolling release version of OpenMandriva, and it also is using OpenSSL 3.5 now. So anyway, there's that, and then we can come over here and we'll look at the commands that I use to install Apache and set up the encrypted website. So it's just nothing out of the ordinary there. These are all the commands which you'd use to install Apache normally. Okay, so uh, uh, you can pause the video if you need to write the commands down, but I mean I'm not going to go through what each and every one of them does. All right. The main thing I do want to point out is that there's no command here to enable and start Apache after doing the installation, because on Debian and Ubuntu type operating systems, that's done automatically as soon as you install the package. All right. But anyway, let's go back over here and look at our default configuration. Okay, and we're going to look at the ssl.conf file that's in the etc Apache 2 mods-enabled directory. And we see here the default configuration here, SSL Cipher Suite, just as high, and disabling the null ciphers. Okay, so basically what this means is that we only want to use the high security type ciphers. Now their definition of high security is going to be a little bit different from my definition of high security, or from the NSA's definition of high security. I'll talk about that more in just a bit. And then down here on this line here, this protocol, or this SSL protocol line here, enables all the protocols but then disables SSL v3. So basically what we're doing there is enabling all of the TLS protocols and disabling all of the SSL protocols. Now the difference there, SSL stands for Secure Socket Layer. That's what the protocol was called originally, and then for some reason Microsoft objected to that name. I don't know why, but anyway, that forced the developers then to change the name of the protocol to Transport Layer Security, so it's now TLS. But all versions of SSL, of the SSL protocol, are considered insecure. So we want to disable all of them, okay? And SSL versions 1 and 2 are already disabled in the actual OpenSSL code. Don't have to worry about that. The only thing we have to worry about in this configuration file is disabling SSL v3. But all versions of TLS, version 1, version 1.1, version 1.2, they're all enabled, okay? And so anyway, let's go ahead here, get out of that, and then we'll go over here to my Chromium browser, and I'm doing this on Chromium because on Firefox I can't find all the menu options I need to do this. So anyway, what I'm going to do here You see here I'm at the test page there on my that's running from my Seduction virtual machine, and it says it's not secure and HTTPS is crossed out. That's only because I'm using a self-signed certificate. Okay, the encryption is still there. It's just that I can't verify the identity of the server because this certificate was not issued by a valid certificate authority. For now, that does not matter. We don't care about that. Okay, all we care about right now is the encryption. And so come over here and come down here to more tools and click on developer tools. And when you come up with this, when you first bring this up, it's going to be on the elements page there. But what you want to do is click on those two little things there and come down here to privacy and security. Click on that, and you see that, yeah, valid certificate is missing because it's not, because it is a self-signed certificate. Again, we don't care about that. What we care about down here is the secure connection settings, and you see there is using TLS 1.3, and it is using the X25519 MLChem 768 algorithms there for the key exchange, and it is using AES 128 for the actual data encryption. Okay, now so we have proven there. We're proving there that yes, the post-quantum algorithm is indeed working. So that's a good thing. And we didn't have to jump through any hoops to do that. It's already working out of the box by default. Okay? Now, the only slight little catch there, if you remember, I showed you on that chart from the NSA, they want us to use MLChem 1024. Now, unfortunately, the MLChem 1024 is not enabled in the OpenSSL 3.5. Only the MLChem 768 is. So yeah, we've got the post-quantum safe algorithm. We just don't have a key length that's as long as what the NSA wants us to use. So hopefully in future versions of OpenSSL, they'll enable the 1024-bit. I don't know why they did not enable it, but it's just not there. Just the 768 is the best you got for right now. On the other hand, we can do something about this AES 128. We can bump that up to AES 256 very, very easily. And to do that, I'll come over here and I will open up the SSL.conf file again. I forgot to point out before, this SSL.conf file is in the etc Apache 2 mods enabled directory. But anyway, I'll open that up again, and I've already got this set up here. All I got to do is just comment that out and remove the comment there, and you see now I am disabling TLS V1, TLS V1.1 and TLS V1.2. Okay, that's because I only want to go with the latest and greatest TLS 1.3. Now, if you have older clients on your network that still require something older than TLS 1.3, yeah, you're going to have problems here. Okay. Now, web browsers should not be a problem. All right. All of your current web browsers will support TLS 1.3. Okay, but if you have other applications, if you're serving out other applications, other types of clients other than web browsers, yeah, there might be a problem. So you have to check that out. Okay, but so we'll do that, and then up here, okay, I'm going to comment this out and uncomment this. Okay, so what I'm doing here is I'm only allowing TLS with AES 256 and SHA 384 hashing. Okay, and to make this work, I have to put this TLS v1.3 in there. Without it, it does not work. All right, so now we can save that, and let's restart Apache, and we'll come over here, and I'll close that, reload the page. Oops, helps to click on the right thing. More tools, developer tools, and yes, indeed, we do have AES 256. So we're not able to get our MLChem up to the 1024-bit key length that the NSA wants, but at least we do have the MLChem, which in itself is a quantum safe algorithm, and we're able to bump the AES 256, the AES up to 256-bit length. So that's good at least, okay? And as I say, hopefully someday, the 1024-bit key length will get added to OpenSSL for the MLChem. Now, another thing I want to point out too is that this is what's known as a hybrid algorithm. And by hybrid, I mean it's using both the X25519 key exchange algorithm, which is not quantum safe, along with the MLChem 768 algorithm, which is quantum safe. And the reason for that is that there are people out there who aren't fully convinced that the MLChem algorithm is fully trustworthy because it's brand new. They don't consider it battle tested enough yet. So what they did is they made this hybrid algorithm, and it does not mean that if your browser cannot use MLChem, it'll just go ahead and do the key exchange via X25519. What it means is that if the key exchange gets past the MLChem, then it still has to get past the X25519. It has to get past both of them, okay, in order for it to work, okay? If the MLChem algorithm says that the key exchange is okay, but the X25519 says that it is not okay, then the key exchange will not work. It will not happen, okay? And so basically, they're using the X25519 as a fallback in case it turns out that MLChem is faulty. Now, that is a very, very controversial decision. A few days ago, I saw a video on YouTube from a quantum safe consulting firm. Well, that's more than a consulting firm. They offer quantum safe products. I forget the name of the company, doesn't matter. But anyway, they're very, very passionate about their belief that these hybrid algorithms just add complexity that is not needed. And they're convinced that the MLChem algorithm is perfectly fine and that we should not use it, okay? That we should use, excuse me, that we should use the MLChem, that we should not use the hybrid, okay? So yeah, they're saying MLChem is good, don't use hybrid. That's what they're saying. But for right now, with the OpenSSL 3.5, the hybrid is all we got. We can't have the MLChem just by itself. The other thing here I want to point out is that it is also possible to create a certificate. Let's see, I got to find the right command for that in my history. There we go. We can make a post-quantum safe certificate using the MLChem algorithm there. However, unfortunately, I tried that and it works fine when I restart the Apache, when I reconfigure the SSL.conf file to use this new certificate and the new key, then yeah, it works fine with as far as Apache goes. It starts just fine, reads it fine, no problem. However, when I go to access it with the browser, then it doesn't work. So apparently the browsers, yeah, they'll recognize the MLChem just fine, but they will not recognize the certificate that's built with MLChem. They'll only recognize the MLChem encryption as part of the running Apache itself. Okay, so we go over here and we look at this certificate then and look at the details, and I don't know if I can get that bigger or not. Let me see. No, I can't. But anyway, we look at the public key algorithm, and it's using RSA encryption, which is interesting because another part of the National Security Agency's chart that I just showed you, it's not in the chart, but it's in the write-up itself, says that RSA is not a quantum safe algorithm, and they're saying now just don't use it. All right. So then we look at the signature algorithm. It's SHA-256 with RSA encryption. Again, they want us using SHA-384 or SHA-512 and to not use RSA encryption. Okay. So yeah, that's that. Okay. So anyway, that's really all I got here for that. All right. Oh well. Other than one other thing, let's just for fun. Let's see if there are any uh, websites out there. Let's look at a couple of banking websites here. See if they're using post-quantum encryption yet. Okay. And we'll go to Citi.com, which is Citibank. That is like one of the biggest banks in the United States, if not in the world. And you don't even have to log in an account for this. Just go to the home page and come over here again. More tools, developer tools. And so yeah, it does have a valid certificate. That's good. We'll look at that certificate and we see signature algorithm, SHA-256. And let's see here. Oh, public key algorithm, RSA, okay, etc. Okay, but we come down here and we see here that Citibank is still using the old school TLS 1.2 with elliptic curve encryption and AES 256. Okay, so elliptic curve Diffie-Hellman encryption, RSA, again, another part of that NSA document that I showed you. It states that both RSA and elliptic curve algorithms are not quantum safe and to just quit using them, okay, along with RSA, right? But anyway, just quit using them. But on the other hand, they're at least using AES 256, so that's good. So definitely not quantum safe connection here. On the other hand, let's go over here to Amherst Bank. Now, Amherst Bank is not the big bank that Citibank is. It is a regional bank. I have no idea why it's doing that. Okay, it only does it with this browser. Okay, only does it with Chromium, but that's okay. We can still come down here and look at this anyway. And again, view the certificate. Well, I can't view the certificate, but anyway, we can come down here though, and we see it is using TLS 1.3, and it is, looky, it is using the 25519 MLChem 768, so I don't know if they've already upgraded their servers to use OpenSSL 3.5 or if they've just used an older version with and they've jumped through the hoops of doing a post-quantum provider. But whatever, at least they're using the post-quantum algorithm there. But down here, they're using AES 128. So yeah, they really need to upgrade that to 256. All right. So anyway, there's that. Okay. So anyway, folks, that's really about it for that. Okay. So really pretty simple stuff. So yeah, OpenSSL 3.5 has that good post-quantum safe algorithms, as a good post-quantum safe algorithms built right into it now. No more jumping through hoops trying to configure a provider and trying to make all the configuration changes for it. It's just already there. The only bad part is that they're still using MLChem 768. They don't have the MLChem 1024 available just yet. So that's all I got, folks. Although I would appreciate it if you'd stick around for a word from my sponsor. All right, folks, it's time for a word from my sponsor, which is me. And listen, if you're a Linux administrator or if you're learning how to be one, you want to know how to lock down your Linux servers to be as secure as possible in order to keep the bad guys out. Purchase links are in the video description below, so be sure to click on the link and grab your copy today. You'll be glad that you did.